So we know that using load cells is complicated with the Xbox Adaptive Controller. The question is, are Hall effect sensors any easier to deal with, especially when we're talking about for the trigger controls, gas and brake, acceleration and brake for games? Well, this is a Hall effect sensor, and these are magnetic sensors. And so, depending on where the magnet is at, they can be triggered. Now, there's plenty of other tutorials out there that talk about Hall effect, so I won't go into a great deal of detail about that, except for the fact that the typical Hall effect sensor you see is configured with a setup that is snap on and snap off. So it's either activated or deactivated because they're used for alarm systems like a door alarm system. They're used to monitor rotation of devices, things like that. Those on and off ones will not work as a trigger because we need analog values. We don't need that on and off digital. We need a continuous range. So what you're looking for is generally called a 49E type Hall sensor, and that is an analog sensor. So it outputs analog values depending on the strength of the magnetic field. So the closer it is or the further away the magnet is will determine its output. Well, you say, great. Maybe that sounds like a potentiometer to me. I could just wire it in. Well, no, it's not that easy. Of course, it's not that easy. Because this does not appear or act like a potentiometer does with the source, sink, and wiper, the three lines that you'll find on all potentiometers. You supply ground to one, you supply power to another, and then you read the value off the wiper. And depending on where the wiper is how much resistance this is showing. A Hall effect does not do that. It outputs an analog range, but not the way a potentiometer does, and not in the values that an Xbox Adaptive Controller is going to look for. So you have the same problem as you have with the load cells, though slightly less complicated. You're going to need a microcontroller in the picture again. And again, this is an Adafruit Cutie Pie, but you could use a big Uno or any other number of microcontrollers. And you're going to need that good old digital potentiometer that I showed in the load cell video. So what's going to happen is that, similar to the load cell, the microcontroller is going to read the analog values off of the Hall effect sensor. It's going to figure out, it's going to have to do some sort of conversion and you're going to have to kind of scientifically practice and see, okay, how far, what values am I getting? It's going to take some experimentation. And then the microcontroller is going to output to the digital potentiometer, which then connects to the port, which makes its way to the 3.5 millimeter jack, which goes into the back of the Xbox Adaptive Controller. But wait, there's more. In order for the Hall effect to work properly and be read from the analog pins, you need to set this up as a voltage divider. So you're also going to need to have a resistor in there. This is just a random resistor, but you're going to have a resistor in there to make a voltage divider. Because that is in effect what potentiometers are, is they are voltage dividers. So when they are fully closed or open, depending on how you think of it, they're sending the full voltage through. Let's say it's 5 volts, they're sending 5 volts through. If they're halfway through, they're sending 2.5 volts. If they're this, they're sending close to 0, or whichever. So the potentiometer acts like a voltage divider. It is a voltage divider. The Hall effect sensor on its own is not. So you need to balance that value with a resistor of the appropriate value, and I have no idea what that is. I would have to look it up, and it depends on the sensor you're using. So you're going to have to set that up too. It's not quite as bad as the load cell stuff, but it's the same problem. You have some sort of input that needs to get to analog for the Xbox. Well, you can have any sort of input, but it's going to have to go through a microcontroller, which is the brains to control a digital potentiometer, and then the digital potentiometer is sending correct values to the Xbox adaptive controller. Now, the cool thing is once you understand and get this part working, you could use almost any kind of sensor on this side. So you could use complicated sensors, you could use radar sensors, distance sensors, any sort of sensor, because you're going to have code on this that's going to interpret that sensor, figure out those values, convert the values to something that the digital pot likes, and then digital pot will control the Xbox. So if you get this part figured out, then you have an opportunity for using all sorts of different sensors, not just Hall effect, not just other stuff, just all sorts of fun stuff. So that's the cool thing. And again, the reason this is because you're trying to go in through the triggers, and the triggers require a resistive load to be sent through there, and you can't send any sort of digital at all. So there you go. Not easy, but feasible and possible.